Hello, everyone, and welcome to Precalculus. This is section 5.3, Solving Trigonometric Equations. It's a little bit of a challenging section, so we're going to break it into some smaller pieces and do it over 3 separate videos. The good news is that trigonometric equations are solved in much the same way as algebraic equations. If the equation is to the first power, you're just going to isolate the variable, or in this case, the trig function. If the equation is to the second power, we're going to set the equation equal to 0 and factor. You have heard me say this dozens of times. Of course, remember that if there's no middle term, then you can square root both sides. So just think about it from an algebraic perspective. If you had something like 3x plus 6 is equal to 1, then you would subtract 6 from both sides, and you would divide by 3. That's what I mean by isolating the variable. But you can't isolate a variable if it's to the second power. Plus 6x is equal to 5. Then you would have to set it equal to 0 and then factor. Now, if you can't factor, you are going to have to use the quadratic equation on an algebraic expression. Fortunately, I won't give you anything that difficult in trig. It does exist, but we won't have to do them here. And of course, lastly, don't forget that if there's no middle term, that looks like this. X squared plus 6 is equal to 9. Then you would say x squared is equal to 3. X is equal to plus or minus the square root of 3. You can only square root both sides when it's just an x squared. You couldn't have done it when it was like that. Sometimes people try and do that, and that's just not correct. So be careful on that. All right, so let's do some trig. So first one, I see it's just to the first power. So I'm going to isolate the variable. I'm going to divide both sides by 2, and I get sine of x is equal to 1/2. So now you get out your chart, and you look to see where sine is equal to 1/2. We did something really similar with inverse functions. And we found out that it is at pi 6. But is there any other place where sine is equal to positive 1/2 pi 6? And since sine is also positive in quadrant 2, the other answer, and make sure you write it below, not next to, I'll show you why in a minute, is 5 pi 6. So you might be wondering, I thought we were only supposed to give the pi 6 answer. And okay, so here's a really important note. If I say when is sine of x equal to 1/2, then I want all the answers. If I say what is inverse sine of 1/2, then I only want pi 6. So inverse sine has a very specific answer. But if in general I just say when is sine of x equal to 1/2, I want all the answers. And at first you might think that there's only 2, but actually not really, because somebody could also say 13 pi 6. They could go all the way around the circle, which is 2 pi or 12 pi 6, and 13 pi 6 is also in the exact same spot. They could go around the circle again and still land at pi 6. So to figure that out here, so if I add 2 pi, that's how I would go around the circle again. I'd be adding 12 pi 6. So that gives me 25 pi 6. How long could I do this? All day long. And I could even go around the circle backwards. So we can solve this problem by just saying plus 2 pi n. N just means if you put a number in there like 1, 2, 3, you could keep adding and going around the circle and keep getting answers. And you could do the same thing with the 5 pi 6. And this is going to be your answer. If that didn't make perfect sense, another way you can think about it is on the graph. The graph of sine looks like this. So here's 1, and that happens at pi halves, and this is pi, and then this is 2 pi. And where is sine equal to 1/2? Well, if I go across, there it's 1/2, there it's 1/2, there's my pi 6 and my 5 pi 6. But then it's equal to 1/2 again here and then here. It's going to keep being 1/2 every time this cycle repeats. And how often does the cycle repeat? What is the period of sine? It's 2 pi. So I have to add that period to account for the fact that it keeps giving me an answer of 1/2 over and over and over again. Fortunately, for those of you that kind of don't get that, you can be safe by just writing plus 2 pi n on both of your answers, but you do need to get both of them. So there is a note on that at the top of the next page, which is in the middle of your paper page. There are two ways you can think about why equations have an infinite number of solutions. You can use the unit circle and think about going around and around and around with coterminal angles. Or you can think about the graph and the period, how it repeats. So either way that makes the most sense to you, you have to add 2 pi n to your answer. Oops, 2 pi n. Okay, let's do another one. So think of this as x plus the square root of 2 is equal to negative x. You would get all the x's together on one side and you'd move all the numbers to the other side. So I can subtract sine of x from both sides. And now I have the square root of 2 is equal to negative 2 sine of x. I divide both sides by negative 2. And I have sine of x is equal to negative square root of 2 over 2. There's always going to be two answers. You're going to constantly be using this concept of forecast, which is what two quadrants is sine negative in? 4 and 3. So you want to give me the quadrant 3 answer. So your reference angle is going to be pi fourths. You can look on your chart and see that sine of pi fourths is the square root of 2 over 2. But since it's negative, I want pi fourths in the third quadrant, which if you look at your unit circle, will be 5 pi fourths. And then I also need to give the answer in quadrant 4 because sine is negative in quadrant 4, and that's 7 pi fourths. And then you just add 2 pi n. Okay. Number 3. 3 cogent tangent squared x minus 1 is equal to 0. So I see a square. So I think I said in the beginning that if you see a square, a second power, you should set the equation equal to 0 and factor unless there's no middle term. So this one doesn't have just a cotangent. It just has the square, which means you can actually go ahead and just solve. Is equal to 1/3. And then cotangent of x is equal to plus or minus, don't forget your plus or minus, the square root of 1/3. Now that's not on your chart because, for two reasons. One, because I don't think your chart has cotangent on it unless you put it on yourself. And also because it would have been simplified a little bit. So we can do this as the square root of 1 is 1 and the square root of 3 can't be done. Now, before you rationalize, remember that cotangent's not going to be on your chart. Tangent is. So let's go ahead and flip it. If cotangent of x is 1 over the square root of 3, then tangent of x is the square root of 3 over 1, or of course just the square root of 3. And that is on your chart. So when is tangent equal to the square root of 3? Well, the reference angle is going to be pi thirds. Now, at first, plus or minus might seem like a headache, but it's actually better because instead of having to figure out what two quadrants it's negative in, like we did above, or which two quadrants it's positive in, you're just going to list all 4 quadrants. Pi thirds, quadrant 2 is 2 pi thirds, quadrant 3 is 4 pi thirds, and quadrant 4 is 5 pi thirds. Notice I left a big gap because I knew I was going to have to add plus 2 pi n to each of them. But actually, do I want to add 2 pi n? Do you guys remember why we were adding 2 pi n? Because that was the period of sine. Sine had these two values, but then after it finished its period, it had those two values again. So every 2 pi n it did. But with tangent, remember that tangent's period is what? Tangent has pi halves, negative pi halves, and then it repeats right away again. Tangent's period is only pi. So what do you think we're going to add to this one? We're just going to add pi n. So this is something you're going to want to put in your appendix, that for sine and cosine, and therefore secant and cosecant, you're going to add 2 pi n. Oops, it was in my head. But for tangent, you're only going to add pi n. Okay, because that's the period of tangent and cotangent. Now, as if this problem wasn't already hard enough, there is a little thing to note here. First of all, this answer is awesome, and I will totally accept this. However, when you go to look in the back of the book, this is not going to be the answer that they give you. They are going to be missing the 4 pi thirds and the 5 pi thirds, and I'll show you why. They're only going to list these two. And you're going to think you made a mistake, but you didn't. Because if you're at pi thirds and you add pi, which is 180 degrees, do you know where you're going to land? You're going to land at 4 pi thirds. So this would be redundant. If you're at pi thirds and you add pi n, you've already got this one covered and you don't need to say it. Similarly, if you're at 2 pi thirds and you add pi, where are you? You're at 5 pi thirds. So it's redundant to say. Is it wrong if you write it? Absolutely not. But I don't want you to be confused when you see in the answer key, they've only listed 2. And this only happens with tangent. So it's the only time you have to worry about it. If you're in the honors class, I would think you would only write those 2. Okay. Okay, next one. Cotangent times cosine squared is equal to 2 cotangent. So the note here is that when you set equations equal to 0 and factor, you don't have to have the entire equation in terms of the same trig function. So I'm going to set it equal to 0. And then I'm going to factor. And don't forget about factoring out first. People forget this kind of factoring, but I can just take it out. I'm not going to factor in 2 parentheses like I sometimes do. Instead, I'm going to just take out the cotangent, and I'm left with cosine squared x minus 2. So remultiply to make sure you did it right. Cotangent times cosine squared is cotangent cosine squared. And cotangent times 2 is 2 cotangent. Believe it or not, the algebra in this section is actually what gets people more than the whole plus 2 pi n thing. This is a tricky concept, is this factoring. So now, like in any other normal equation, you would set both factors equal to 0. And you can solve them independently. Remember that with cotangent, we're going to switch it to tangent. And then we're going to do 1 over 0. Ooh. Now what? You can never divide by 0, right? So it's undefined. Well, when is tangent undefined? Tangent is undefined at pi halves and at 3 pi halves. And then, of course, you can write, because it's tangent, plus pi n and plus pi n. But if you think about it on the chart or on the unit circle, here's pi halves. And if I add pi, where am I? 3 pi halves. So it is redundant, and you only need to say one of them. But some of you are really going to like writing both because it'll make you feel like you understand it better. All right, we still have a whole other half of the equation to do. Cosine squared, I can just solve it regularly because there's no plain cosine. I don't have to factor, is equal to 2. cosine squared x is equal to plus or minus the square root of 2. And this, sorry, just cosine of x is equal to plus or minus the square root of 2. And this is not on your chart. The square root of 2 over 2 is on the chart, but not just the square root of 2. And actually, if you change that to a number, it's plus or minus 1.4. When is cosine equal to 1.4? Let's think about the graph for a second. Cosine starts at 1, and it goes down to -1, and then up to 1, and then down to -1, and up to 1. Where's cosine equal to 1.4? That was such a terrible graph. Where's cosine equal to 1.4? Never. Okay? So if this equation is ever equal to 0, it's not because of this factor. It's because of the cotangent. So the only answer is the one I've already boxed. There's not a second answer to this. Okay, I do have a huge warning on this problem. I put something very similar on a quiz or a test, and a shocking number of people get it wrong. They start off, they get it wrong on the very first step, and then there's no recovering, which on a 7-point problem is really hard. So cotangent of x, their very first step is to divide both sides by cotangent. I understand why you would want to do that. And then they just have cosine squared x is equal to 2. But, which is this one right here. But what you've done is you've divided away a variable. You've divided away the possibility that cotangent of x could be 0. Because if cotangent of x was 0, then both the two sides would be the same. So you've literally not just eliminated cotangent, you've eliminated an answer, and that's why it's wrong. I cannot stress enough, set it equal to 0 and factor. Dividing variables away is never allowed. It's even true just with x's. If you have x squared is equal to x, and you divide both sides by x, then you're going to think the answer is 1. But that's not true. If you set it equal to 0 and factor, you'll see that the answers are 0 or 1. Two different things would solve that original equation. So never divide away a variable, only divide away numbers. All right, as you can see, you can now do homework for day 1. So I'm going to stop the video here, but video 2 will do the next little section.